let's predict together if these three compounds are aromatic compounds, non-aromatic, or anti-aromatic. Okay. All right. Let's start with the left one, cyclopropyl cation. Okay. To determine if it is aromatic compound or not, this guy has to meet all the three criteria. Does that make sense? All right. Need to be planar, cyclic conjugated pi system, and the pi electrons must follow 4n+2. Okay. All right. Start with planarity. 3 carbons. Can this guy be non-planar? 3 carbons? No, you can't. You gotta be planar. This one for sure. 3 carbon. All right. Now, cyclic. Of course, this is a cyclic compound. Does it have a conjugated pi system? If you remember, also, what is a conjugated pi system, by the way? So p orbital next to p orbital next to p orbital next to p orbital. Do all 3 carbons have p orbital? This one for sure, right? There's an sp2 carbon. This one for sure. P orbital is pi bond, right? So p orbital, p orbital. What about this one though? We call this guy a carbocation. What does carbocation contain? It has an empty p orbital. It is an sp2 carbon, right? Have an empty p orbital. So basically, all 3 carbons have 1 p orbitals each. So they are cyclic and conjugated pi system. Okay. All right, now next one, 4n+2. If you remember, 4n+2 follow the Huckel's rule. The number of pi electron must be 2, 6, 10, 14. Okay, so how many pi electrons are there? 1 and 2. That's it, just 2. This guy is aromatic compound. Okay, so 2 is the lowest number of pi electrons that allow a compound to be aromatic. 2 is the lowest. Okay, all right, move on to the cyclopropane. All right, first off, we have the aromatic compound here. Cyclopropane, all right, we have same thing, 3 criteria. For sure, that guy is an sp3 carbon, doesn't have p orbital, is not, doesn't have conjugated pi system, so it's no. This guy is non-aromatic compound. Okay, all right, move on to the last one, cyclopropyl and anion. All right, same thing. All right, is it planar? Well, 3 carbon, it gotta be planar. Okay, all right, cyclic, look like a cyclic to me. Conjugated pi system. That is, I have a pi bond. All right, we have to go back, review real quick. So can you draw a resonance structure right here from this lone pair? Yeah, you can. An allylic lone pair is delocalized, if some of you remember. Okay, so it looks like an sp3, but this guy can put the 2 electron on an sp2 and have the resonance stabilize at negative charge. Okay, so basically this lone pair on this carbon is on an sp2 orbital. I said wrong. It's on a p orbital. This carbon on an sp2. Okay, the lone pair is on a p orbital. Allow this guy, all this carbon, 4 electrons or 2 pair to delocalize. So yes, cyclic conjugated pi system. And the last one, 4n+2. Well, how many electrons are there? Pi electrons are there? 1, 2, 3, 4. 4 down here follow 4n format. So it's not 4 pi electrons. So it's not. This guy is an anti-aromatic compound. Okay. Now you might have a question: how do I tell the difference between non-aromatic and anti-aromatic? Anti-aromatic have a planar conjugated pi system, but have an open shell. This one is an open shell. Okay. Non-aromatic, not planar, doesn't have conjugated pi system. Don't even talk about the Huckel's rule. Can't even meet the first 2. Either one of this. Okay. All right. Let's take a look. The one that compare between aromatic compound and an anti-aromatic compound. Okay, the aromatic compounds, if you remember, is it got to have a closed shell. All right. Now, so we're gonna use Frost diagram to show. This I have 2 pi electrons. So start. How do I fill up? Start from the bottom, 1 and 2. That's a closed shell. Okay. Cyclopropyl and anion has 4 pi electrons. So we're gonna go 1, 2, 3, and 4. That's an open shell anti-aromatic. That's how you do it. Okay, all right, we're going to move on to see some other aromatic. Okay, next one we're going to call aromatic ion. It's an ion just like this. All right, I'll show you a couple.